Carbon Footprint. Part 3. ISO 14067. Recap on we had learned from previous video. Firstly, the ISO 14060 family provides clarity and consistency for quantifying, monitoring, reporting and validating or verifying GHG emissions and removals. Application of the ISO 14060 family include application in corporate decisions, such as identifying GHG emission reduction opportunities and increasing profitability by reducing energy consumption. Also, in carbon risk management, such as the identification and management of risks and opportunities. The international standard ISO 14067:2018 carbon footprint of product specifies principles, requirements, and guidelines for the quantification and communication of the carbon footprint of a product, CFP. This international standard addresses only one impact category, climate change. This is some keyword in this part that you need to know. In this part, we will talk about general requirement, goal and scope, inventory analysis, impact assessment, interpretation, and limitation. So, we will start with general requirement first. There are 3 types of requirement needed. So, we will go to first type of requirement, which is what need to be done if relevant PCR or CFP PCR exist. Okay, first, it have been developed in accordance with ISO 14025 or any other relevant ISO sector-specific standard. Second, it need to be complied with requirement of 6.2, 6.3, 6.4, Clause 7 and 9.5. Last but not least, it need to be considered proper by the organization applying this international standard and are accordance with principle in 5.2. Okay, for next type of requirement is when more than one set of PCR or CFP PCR exist. When this happen, it shall be reviewed by organization applying this international standard and the choice of PCR or CFP PCR adopted shall be justified. Next type of requirement is when there no relevant PCR or CFP PCR exist. The requirement and guidance of other internationally agreed sector-specific documents which related to specific materials should be adopted when this situation happen. Okay, we will move to goal and scope of CFP. The goal of CFP study is to calculate the potential contribution of a product to global warming expressed as CO2e by quantifying the GHG emissions and removals over the product's life cycle. Next is the item that defining the goal. First item is the intended application. Second item is the reason of carrying the CFP study, and the last item is the intended audience whom the result intended to be communicated. Next is the scope of CFP study. There are 11 scopes in CFP study. First scope is the product system to be studied and its functions. Next is the functional unit followed by system boundary. Fourth scope is method to address issues, and fifth scope is land use change, LUC. Next scope is data and data quality requirements. Allocation procedures. Time boundary of data. Assumptions. Limitations of CFP study and CFP study report are also the scopes of CFP study. Carbon footprint inventory analysis. Life cycle inventory analysis is a compilation and quantification of inputs and outputs for a product throughout its life cycle. Carbon footprint life cycle inventory analysis must be performed by following steps adapted from ISO 14044:2066. However, if carbon footprint of product and product category rules, CFP PCR, are adopted for carbon footprint study, life cycle inventory should follow requirement in CFP PCR. Qualitative and quantitative data will be collected for all unit processes included in system boundaries. Data will be measured, calculated, and estimated. If data collected from public sources, it should have details about data collection process, data collection time, and further info about data quality. It also should be referenced in CFP study report. However, it should be stated if the data not meet data quality requirement. Site-specific data needed for data collection included greenhouse gases emissions, sources, removals, and GHG sinks. It also included activity data, which is inputs and outputs of process resulted on GHG emission or removal, or direct GHG emission data that can be determined through direct monitoring, stoichiometry, mass balance, or other similar method. To reduce bias and uncertainty data of CFP study, data quality requirements should be specified, so that goal and scope of CFP study can be met. These are 10 requirements of data quality requirements, such as time-related coverage, precision, consistency, and many more. Validation of data should be conducted during process of data collection. It involves establishing such as mass balances and energy balances. Each unit process must obey the laws of conservation of mass and energy. For relating data to unit process and functional unit, it should have appropriate flow to be determined for each unit process. Quantitative inputs and outputs data should be calculated in relation to the flow, and calculation should relate system input and output data to the functional unit. When aggregating the inputs and outputs in the product system, it should be done carefully, consistent with goal of CFP study. And if additional details aggregation rules are required, it should be explained in goal and scope definition phase of CFP study. To refine the system boundary, decisions regarding data included should be based on sensitivity analysis to determine their significance. Initial system boundary should be revised according with cutoff criteria established in definition of scope. Refining process and sensitivity analysis should be documented in the CFP report. Sensitivity analysis may result in exclusion of life cycle stage or unit process when lack of significance can be shown by the sensitivity analysis. Next, exclusion of inputs and outputs that lack significance to the result of CFP study, or maybe inclusion of new unit process, inputs, and outputs that are shown to be significant in the sensitivity analysis. Allocation of inputs and outputs to different product according to the clearly stated and justified allocation procedure. Sum of allocated inputs and outputs must equal to the inputs and outputs before allocation. If there are applicable alternatives allocation procedures, sensitivity analysis should be conducted to know the sequences and departure of selected approaches. There are 3 steps in allocation procedures. First, allocation should be avoided by dividing unit process into 2 or more sub-process and collect data related to sub-process. Second step is when allocation cannot be avoided, so that input and output should be partitioned between different products and function. Lastly, step 3 is where physical relationship cannot be established or used as the basis of allocation. So, inputs should be allocated between product and function to reflect relationship between them. Allocation for reuse and recycling have same characteristics with previous principles and procedures. However, some additional elaboration needed for some reasons, such as inputs and outputs associated for extraction, processing raw material, and final disposal shared by more than one product system. Besides that, reuse and recycling may change the inherent properties of material in subsequent use. There are 2 types of allocation procedures for the constraint addresses. First, closed-loop procedure that applicable to closed-loop product system. It also can be used for open-loop product if no changes occur in the inherent properties of recycled material. Next, open-loop product procedure applies to open-loop product system when materials recycled into other product systems and undergoes a change to its inherent properties. Basis of allocation are physical properties such as mass, economic value, and number of subsequent uses of recycled material. 4. Impact assessment of carbon footprint. You will learn how the procedure in analyst the impact for carbon footprint. Before we go deeply, let's know the introduction for life cycle impact assessment. It is the third phases of LCA according to the ISO 14040 standard. It contributes the elementary flows from the life cycle inventory into their potential contribution to the environmental impact. It also support interpretation phase for their analysis. Let's know the 5 steps of life cycle impact assessment. The first step is selection of impact category indicators, and characterization models. Next is assignment of LCI results to the selected impact categories, or known as classification. Next is calculation of category indicator results or characterization. Next is calculating the magnitude of category indicator, the result, relative to reference information or known as normalization. Lastly is converting indicator results OD different impact categories by using numerical factors, based on value choice, or known as weighting. Impact 2002 plus, it divided to 2, which is 13 midpoint categories and 4 damage categories. In midpoint categories, it has carcinogens, respiratory, no carcinogens, inorganic, ozone layer depletion, ionizing radiation, respiratory organics, terrestrial ecotoxicity, aquatic ecotoxicity, terrestrial acidification, land occupation, non-renewable energy, and global warming potential. For damage categories are climate change, human health, ecosystem quality, and resources. We continue our impact assessment on categories and method. It has 5 categories that started which classification. It assigning each value that has been compiled in the resources uses and emissions profile to the relevant environmental footprint impact categories. For characterization, it is multiplying the value compiled in the resources use ANS emissions profile by the relevant characterization factor for each impact category. Normalization is calculate the magnitude of category indicator results relative to some references information, which should be relate considering the spatial and temporal scale of the study. Grouping is the impact categories are sorted and ranked. Lastly is weightings. It is an additional optional step that may support the interpretation and communication of the results of the analysis. After we know the categories and method in impact assessment, let's continue which example of step in impact assessment. The steps started when it get the results from inventory analysis, such as when the results is carbon dioxide, it will classification in climate warming, same to others results. Next when at characterization, the climate change will characterizes under global warming potential. Same with other results. In normalization, all of the results such as GWP, ODP, and AP, it will relative to certain area and time. Next is grouping. All of the results will set according to impact categories such as high, medium, and low priority. And lastly is weightings by one figure. Interpretation of carbon footprint. The life cycle interpretation phase of CFP study comprises the following steps. First, identification of the significant issues, based on the results of the quantification of the CFP, according to LCI and LCIA phases. Second, an evaluation that considers completeness, sensitivity, and consistency checks. And third, conclusions, limitations, and recommendations. The results of the quantification of the CFP according to the LCI or LCIA phases shall be interpreted according to the goal and scope of the CFP study. The interpretation shall include a quantitative or qualitative assessment of uncertainty, including the application of rounding rules or ranges. Next, identify and document the selected allocation methods in the CFP study report in detail. And lastly, the interpretation also shall identify the limitation of the CFP study. In this step, the interpretation should include these 3 requirements, where it is included a sensitivity check of the significant inputs, outputs, and methodological choices, including allocation methods, in order to understand the sensitivity and uncertainty of the results. Interpretation also should include an assessment of the influence of the alternative use profiles on the final results. And lastly, an assessment of the influence of different end-of-life scenarios on the final result also included in interpretation. Next, we will learn about limitation of carbon footprint. Limitation of CFPs affect both CFP quantification and CFP communication. These 2 most important inherent limitations are: first, focus on a single environmental issue. Second, limitation related to the methodology. In focus on a single environmental issue, the CFP reflects the sum of GHG emissions and removals of a product system, expressed as CO2 equivalent, which are associated with raw material acquisition, the production, use, and end-of-life treatment of a product. While the CFP can be an important environmental aspect of the life cycle of a product affecting the safeguard subject climate, a product's life cycle can have other environmental impacts of concern, e.g. resource depletion, air, water, soil, and ecosystems. An objective of LCA is to allow an informed decision regarding environmental impacts. Climate change attributable to the CFP is only one of a variety of environmental impacts that can arise from a product's life cycle, and the relative importance of different impacts can vary with different products. In some cases, action to minimize a single environmental impact can result in greater impacts arising from other environmental aspects, e.g. activities to reduce water pollution can result in increased GHG emission from the life cycle of a product, while the use of biomass to reduce GHG emissions can negatively affect biodiversity. Decisions about product impacts that are only based on a single environmental issue can be in conflict with goals and objectives related to other environmental issues. Where information regarding CFPs is used to inform consumer decisions, consideration shall be given to the potential importance of other relevant environmental aspects in the life cycle of that product. While, in limitations related to the methodology, the CFP is calculated based on LCA methodology. ISO 14040 and ISO 14044 address its inherent limitations and trade-offs. These include the establishment of a functional unit and the system boundary, the availability and selection of appropriate data sources, allocation rules and assumptions regarding the transport, user behavior, and end-of-life scenarios. Some of the chosen data may be limited to a specific geographical area, e.g. national electricity grid, and or may vary in time, e.g. seasonal variations. Value choices, e.g. for the selection of functional unit or allocation rules, are also needed to model a life cycles. These methodological constraints may have an influences on the outcome of the calculations. As a result, the accuracy of quantifying the CFP is limited and is also difficult to assess. Hence, other approaches such as energy consumptions in use assessment may be preferable in certain circumstances. However, establishing the importance of use stage GHG emissions is not possible without first assessing the life cycle GHG emissions of a product. As a result, CFP communication needs to consider the most appropriate information to be made public, once a fuller assessment has been completed. Because of the above limitations, the results of a quantification of the CFP in accordance with this international standard are not a sound basis for comparisons. However, these results may be used for comparisons provided that at a minimum the requirements, including requirements for a separate program, are met. Hey guys, let's have some quizzes. Okay, for the first part, statement below related to which general requirement? The answer is yes. You are correct. No relevant PCR or CFP PCR exist is the right answer. Let's go to the next question. What happened when more than one set PCR or CFP PCR exist? Yes. It shall be reviewed by organization applying this international statement, and the choice of PCR or CPR PCR adopted shall be justified. Okay, to the next part. Which one is not the item in defining the goal of CFP study? Yes, towards sustainability lifestyle is not one of the item. Okay, for the last question for goal and scope part. How many scope are there in a CFP study? Thumb up. You are correct. There are 11 scopes in CFP study. What should you do when data quality requirement cannot be achieved? Yes, the answer is you should state it in the report. Okay, next question. When allocation cannot be avoided, you should C for correct. Input and output should be partitioned between different product or function. Quiz 3.4, on impact assessment. What is the third steps in impact assessment? You will give 10 seconds to answer this question. Alright, let's recheck the answer. First is classification, second is characterization, fourth is grouping, and fifth is weighing. Answer for third step in impact assessment is normalization. We go to next question. List out 5 midpoint categories in Impact 2002 plus. You will give 10 seconds to answer this question. Good jobs. These are all the list answer provided for this question, which are non-renewable energy, global warming, ozone depletion, respiratory organics, aquatic ecotoxicity, terrestrial acidification, land occupation, respiratory, no carcinogens, inorganic, ionizing radiation, carcinogens, and terrestrial ecotoxicity. In interpretation, the life cycle interpretation phase of CFP study comprises how many steps? Correct. The answer is 3, which is identification, an evaluation, and also conclusions. Next question. The results of the quantification of the CFP according to the LCI or LCIA phases shall be interpreted according to the goal and scope of the CFP study. Yes or no? Correct. The answer is yes. Let's move to limitation part. Is it true when limitation of CFPs affect both CFP quantification and CFP communication? Yes, good job. The answer is true. And for last question, which are most important inherent in limitations? Yes, good job. The answer is focus on a single environmental issue and limitation related to the methodology. When in limitation, they have two most important inherent limitations. Stay tuned and thank you for watching.